Okie dokie. So let's switch to the Kropki squares, which means that for such a dot, it indicates a quadruple, and in this quadruple there are two cells that form a 1 to 2 relationship. So it's like a black Kropki dots, and another two cells will form a white Kropki dots, so they will be consecutive. So let's try to do that as well. That's not a global constraint. And of course it would be a custom one. But in this case we just need to provide the group of cells. Let's just make sure that it has some name. Okay, Kropki square, blah, blah. Looks like that's it. And the arguments for the constructor are pretty much standard, looks like. So we can just do it like that. And let's add some groups. It doesn't look like it matters which order we specify it in. Yeah, let's start from this. I don't have to input everything. Here we also don't have anything smart to do rather than just iterating over all possible combinations and checking each one of them independently. So looks like we have A, B, C, D. So basically it's not important which order the cells are in the Kropki dots. It's more important like that the first two of them would be the black Kropki, the second two will be the white Kropki. And of course we can like do all this, prepare these combinations with some algorithms, but it's just easier to do manually. So the last one is CTAB. So we have all combinations. Let's call it cells again. Yeah, actually let's prepare them from the start. So basically we need to check that one of them, these two, are ratio, these two are difference. Actually, let's do it like that. So these are the cells, and these are That's the IDs, and these are the candidates. Okay. So how could we know that two cells could be a ratio? I guess again, just go over all possible candidate. Yeah, it's quite hard to make meaningful names for the variables when there are too much of them, but let's deal with that. So we have possible candidates for the first cell, and we need to check that the second one is a ratio of that. So if it contains the same twice, let's prepare the result, then we're good. If it contains the same divided by 2, then we're also good, but we need to check that dividing by 2 makes sense. So now we know if it's a ratio or not. And if it's not, that it's nothing to do here. And I guess we could do the same for the difference Kropki. Okay, check if it has one less or one more. Okay, so now we know that this particular combination could be a valid quad. So I guess let's collect all of them. What is that? Cells. Okay. And now if we don't have a valid quad, then the puzzle is probably broken. And we can exit from the function again, like we don't need to do anything else after we stop the puzzle. And if we have exactly one valid quad, then we probably can simplify it. So these are the cells. So instead of the current component, we could just say, here we have the ratio. Let's check that I read the name. Yeah, I did. We have the ratio of 2 for the cells A and B. Difference. Yeah, difference component between the other cells, and it probably does expect the same arguments. Name, difference, cell. Oh, they don't expect the cells as an array. They expect them like that. Okay, so I need to do each one separately, and maybe that would be good for the starters. Let's see if we can. Oops. Oh, here we go. Again, do the validation. Whoops. Okay. So let's see if it could do something. Let's say we have a 7 here. And let's say we exclude 6 and 8 from these. Oh, that obviously doesn't work. Let's say we exclude 6 and 8 from these. Now it understands that this is the white Kropki dot, this is the black Kropki dot, and it continues running. Of course, the puzzle is impossible. Yeah, but it looks like it's already good for the brute force solver. So let's. Oh, I don't need to do that. I just need to add more inputs. Boom. 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 Let's see if it's fast enough. Oh, it took like 0.0 seconds. So yeah, it's already very good for the brute force solver. Of course, it's not quite enough for the logical solver, but I guess that's okay. For instance, let's check if we write, let's say a 7 here. What can it do? It says the puzzle is broken. That's funny. How did I manage to break it so fast? Yeah, that's one of the troubles for the custom components. Like it doesn't tell where exactly it's broken, and there's no way to do that. But let's try 5 maybe. Okay, Oh, it's broken probably because that could not be 1, 3. I don't know. Really don't know. Yeah. So, for instance, right now the logical solver stops here. But if we think as humans, we know that none of these cells could be 7 or 9, because there is some basically we know that 5 is the part of the white Kropki dot, because it cannot be in a 1 to 2 ratio with anything. So we cannot have one more digit that is that cannot be in a ratio. So let's try to fix that. And what we can do for that is, again, just the power of the brute force. So we basically know which candidates work for which cells. So let's just collect them and use them. So what do I call it? Filter. F as for filter. So digit set, just a new one because it's empty. So now when we know that some candidates works for the cell, we could add it. So add the VA to here, add this one as a candidate for B, so in the end of it all, we must know which exactly candidates could work for that, and we can use that. But we need to collect it for all the cells somehow. So I guess like we need to map them by indexes somehow, I guess. Something like that, probably. Okay, so here we will aggregate all the possible values for the cells. So, and we index them by the cells. Okay, so let's see, what we need to do now is, when we know that the option works, we can add it like that, like add all possible candidates that we collected. So in the end of it all, the map should contain everything. So we probably could do that before. So filter candidates in cell and do something like that, I guess. We probably could remove all of that. And that's not needed anymore. Yeah, basically the reason why I do it first is because even if we want to replace the current component by some simpler ones, maybe we can do some eliminations even before that. So why not? We can do multiple eliminations in one step. That's totally fine. And it says that it's broken. That's a worry. Oh, what's that? Okay, well, that's probably was the issue. Oh, I know what's the issue. The issue is that I stopped checking after finding the first candidate, of course. Yeah. Now it should be okay. Yes, thank you. Yeah, it took some time, and it was a usual mistake. That happens. No logical steps from the start, of course, but now let's check that one. Yeah, you see, now it excluded 7 and 9 from everything here. So now could be the good time to check if it could solve the puzzle just by contradictions. Yeah, it does it quite easily. Yeah, usually if the solver could do it by contradictions, then the brute force solver will be very fast as well.